All right, CNT120, Chapter 2. We're continuing our discussion on the cable infrastructure in our commercial building. We're picking up some of the miscellaneous pieces. We talked racks and patch panels. Now we'll talk these last couple pieces. They mentioned voice over IP equipment. Voice over IP literally stands for Voice over Internet Protocol, also known as IP telephony. It's the use of any network to carry voice signals using TCP/IP protocol. This is actually pretty common today. So in my data closets or in my closets, I'm going to most likely have some voice over IP equipment. So I'm going to fill you in. Starting at my work area, I'm going to have a special IP phone, most cases. And actually, if you look around, you often see these different places too. These are designed to plug into a network port. So this will plug into the data port on the wall. And this is actually going to get power from the switch in the closet. So this will plug into the data port on the wall and basically use the cabling that goes back to the closet, back to the patch panel. Right here, here's my IP phone using a regular old data port back to the closet into a switch port. Well, this switch port needs to be capable of what's called power over Ethernet. It'll actually give that phone power through the Ethernet connection, through the data wires, actually used through the unused data wires, or we'll leave it like that. We'll keep it that way. Keep it simple. It's going to actually provide it DC power across the data lines, data wires, to that phone to power. This allows the phone to be located anywhere in an office and it'll receive power. There's more reasons, but that's the simple one. So the switch itself needs to be capable of power over Ethernet. And this little graphic, little picture I found shows you this particular switch is capable of power over Ethernet on a number of the ports. So it is able to power IP phones. It's actually also able to power access points, IP cameras, and other things. But since we're talking IP phones, it's actually going to power the IP phone. Okay. What's also going to be in your closets, if I just look at something simple like this guy over here, my IP phones. Actually, we'll look at this one over here. This one actually has the IP phones in. IP phones will be plugged in the power over Ethernet switch, and that is going to be plugged into my network, and I will have most likely a voice over IP gateway router, a router that's able to process IP phone traffic and pass it to a provider, a SIP provider, if you will. So in my closet, I will have some additional gear for my IP phones. And it might be a voice over IP gateway router. It might also be a phone server, for lack of a better term, a IP PBX. And it might actually be a phone server sitting in there to process those phone calls and deal with voicemail and that sort of thing. So with voice over IP equipment, I'm going to have special IP phones. I'm going to have an IP or a switch capable of powering the phones and moving phone data through, and I'm going to have some other device like a voice over IP gateway router or server in my closet to process those phone calls. When you deal with your closet, you'll have some additional equipment in there for IP phones. That is pretty common. They also mentioned different types of punch-down blocks, 110 and 66 punch-down blocks. This was in the little gray paragraph on legacy, but you should at least be aware of them to know what you're seeing if you see them on the wall. 66 blocks were used primarily for phone connection. They were just a plain old workhorse for phone connections, and you're still going to see them, and places still do use them for phone wiring. You also run into 110 blocks too. 110 blocks are used primarily for phone and also for data. I should say mainly for phone, but also for data too. Here's a close-up of a 66 block, this guy right here. Well, here's the 66 block, and here's a close-up showing you rows of pin that you lay the wires in and use a punch-down tool to push them into that metal V. And the idea of the 66 block was phone lines from the phone company come into one side of the block, gets punched in. Your phone system wires get punched in the other side, and you use little metal clips in the middle called bridge clips to connect those two sides together. That was the purpose of your 66 block. And here is actually a whole wall of 66 blocks, connections between phones and your phone system in the building. So if you see these on a wall, that is for some type of phone system that's being used. Meanwhile, a later on replacement for the 66 block was the 110 block. This was designed to be that block that was capable of doing phone and data. And it was able to do data for lower speed data, like the 100 meg data kind of thing. Gig and 10 gig, it's just not capable. There's too much untwist involved. But your 110 block looks like so. And how it worked was you laid the wires in here, then punched another clip on top, and then punch wires on top. And here's a whole wall of 110 blocks. Again, this is all phone wiring, but this could carry data, lower speed data. That's why I say you don't find it so much anymore because of the too much untwist required for terminating these. So these are, as they say, kind of legacy, but it's worthwhile to know them in case you see them and you recognize what you're seeing. Another thing you'll find in most data closets is a KVM or KVM switch. Your KVM switch is your keyboard, video, and mouse switch. It's designed to be a single console for maybe many servers that you have in your rack. So if you have 5 or 6 servers in your rack, you're not going to have 5 monitors, 5 keyboards, 5 mice kind of thing. That's just kind of ridiculous. So what you do is you take this KVM, and here's actually a cabinet that you would have a couple servers in. I will have one console here, monitor, keyboard, mouse kind of deal, and that actually has a KVM switch built into it to connect to the multiple servers. And here's actually showing you one with a number of connections that you can connect to multiple servers in the rack. So that little console comes in here, and it has connections to go to a number of different servers that you might have in your rack. And that allows you to use that one console to connect to any one of them. Okay, that's your KVM switch, very common. So when you start seeing a closet with this kind of keyboard and screen, and chances are it's a KVM to connect you to multiple devices in the rack. Last thing they mentioned in our cabling part is your patch cables. Yes, indeedy. Patch cables are your short cables, usually in the 3 to 20 some feet ballpark. Remember, there is a 90-meter cable run, and the remaining 10 meters is left over for patch cables. So you have, 20 to 30 feet of patch cables available to you to use. So each end might have a 10 or 20 foot cable on. So your patch cable is that short cable with basically connectors RJ45s on each end. Designed to connect the PC to a data outlet at your work area. Also designed to connect your patch panel port to a switch port in your closet. So your patch cables are the cable that goes from your workstation into the data outlet in the work area. It's also the cable that's used in the closet to go from patch panel to switches. Okay, and here's your patch cable here. Most of you are very familiar with what these look like. They do have a very particular pinout. The color code order is important to be able to move data across it correctly. There is an A pinout and a B pinout for making connections. Let's continue on. Actually, I will pause here. I'll come back in the next one and talk cable management.